This is recording 1A on radical equations for Unit 5, Chapter 5, Mathematics 2200. We'll be looking at solving equations involving square roots with variable radicands. Case 1. What happens if we have just a single square root? And this is a radical equation because we have a variable involved in the radicand. First step is determine the restrictions on the variable. So we have a single radicand, y minus 1. And that has to be greater than or equal to 0 because we have an even index. So y has to be greater than or equal to 1. Now the first real step though in solving the equation itself is that we isolate the radical. So we bring that 1 that's right here over to the left side. And that leaves us with y minus 3 equals root of y minus 1. Square both those sides. And when we square y minus 3, we can do that the quick way we learned in Chapter 3, or you can realize you could use FOIL. But right here, the square root and the square are inverse operations, so they're canceled. We get y squared minus 6y plus 9 equals y minus 1. I have to solve this. It's a quadratic. I'll need a new slide for this. For quadratics, we'd like to have them equal to 0, so we've got y squared minus 6y minus y plus 9 plus 1 equals 0. Gives us y squared minus 7y plus 10 equals 0. I'll choose to use factoring. Y minus 5 and y minus 2 equals 0. So y minus 5 equals 0 and y minus 2 equals 0. We set each factor equal to 0, giving us y equals 5 and y equals 2. Our restriction was that y had to be greater than or equal to 2. Well, both of these are greater than or equal to 2. However, that's not enough. We also have to check in the original equation. So if we check y equals 5, 5 minus 2 gives us 3. When we put the 5 in on that side, and we've got root of 4 plus 1 when we put the 5 in there. 4 is 2, 3 is obviously equal to 2 plus 1. Likewise, we put the 2 in, 2 minus 2 is 0 for this side. We get root 1 plus 1, 0 is not equal to 1 plus 1. So it turns out though that even though 2 passes our restriction, it is still extraneous. I write that down. Now we move into our next example. And this one involves 2 radicals. So we've got 2 restrictions to do. So therefore, 3x minus 5 has to be greater than or equal to 0. 3x is greater than or equal to 5, which means x is greater than or equal to 5/3. The other radicand is x minus 2. That has to be greater than or equal to 0, so x is greater than or equal to 2. So it appears we have 2 restrictions, but really, if any number is bigger than or equal to 2, it's also bigger than or equal to 5/3. So we only need to keep that restriction. To begin the process of actually solving the equation, we isolate what looks like the more complicated radical, so that would be the root of 3x minus 5. Equals root of x minus 2 plus 3. Now we square both sides. So I've got root of 3x minus 5 equals root of x minus 2 plus 3, but I square each side completely. On the left side, the radical, the square root, and the squaring are inverse operations. So I've got 3x minus 5 equals, on the right-hand side, I'm going to have to do FOIL there. I can't just square the individual terms. So I've got root of x minus 2 plus 3 times root of x minus 2 plus 3. So I have to multiply my first term by my first term. They're like, that's the same radical, multiply by itself, so I just lose the radical sign. So I'll get x minus 2 for that. And then I've got 3 times 3, which is 9. Then I've got 3 root of x minus 2 right here. And I'm going to have another 3 root of x minus 2 right here. So to summarize that, I have 3x minus 5 equals x minus 2 plus 9 plus 3 root of x minus 2 plus 3 root of x minus 2. These two are like radicals. So I've really got 3x minus 5 equals x minus 2 plus 9 is plus 7 plus 6 root of x minus 2. I now have to isolate the 6 root of x minus 2. So I subtract x from both sides, I'll get 2x. And subtract 7 from both sides, I'll get minus 12 equals 6 root of x minus 2. Now I square both sides again to get rid of that last root. So squaring the left side by multiplying it by itself, 2x minus 12 times 2x minus 12, I get this. On the right side, I square the 6 to get 36, and I got x minus 2 because I lose the root. So I've got 4x squared minus 48x plus 144 equals 36x minus 72. And making it all equal 0, I've got 4x squared minus 84x plus 216 equals 0. Dividing everything by 4, I get x squared minus 21x plus 54 equals 0. And by factoring, I will wind up with x equals 18, x equals 3. So I begin by putting the 18 in the original equation, and I get 3 times 18 minus 5 is 49, 18 minus 2 is 16. That gives us 7 minus 4, which gives us 3. That's good. On the other hand, when I put a 3 in, put our solution of 3 in, I wind up with 2 minus 1 gives us 3, but that's not true, so therefore x equals 3 is extraneous. To conclude, when solving radical equations, follow these steps.